Hi everyone, in today's lesson I will give you the revision on chapter 10, more about trigonometry. So the first part of this chapter is trigonometric ratios of any angles. Okay, so please take a look of the xy axis. So this xy axis separates the paper into 4 areas, and we will call these areas as quadrant, and they are quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we define these 4 quadrants using the angles. So let's start with the positive x-axis. It is the 0 degree. And for the positive y-axis, it is 90 degree, and so on, 180 degree, 270 degree. And finally, when we come to one rotation, it is 360 degree. Okay, so as you can see, from 0 degree to 90 degree, it is quadrant 1. And then from 90 degree to 180 degree, it is quadrant 2. And so on. From 180 degree to 270 degree, it is quadrant 3. And finally, 270 degree to 360 degree, it is quadrant 4. Then we want to construct some triangles in these 4 quadrants. Okay, so there is a pattern. Please be remembered that butterfly. Okay, so they will look like this. So for each quadrant, there is a particular triangle. Okay, so the 4 triangles will look like this. And next, and don't forget the angle that we are considering. And one more thing in this figure, that is the A, S, T, and C. Okay, for A, it represents in quadrant 1, sine, cosine, all of them are positive. Okay, and for S, it represents in quadrant 2, only sine theta is positive. And then for T, it represents only tangent theta in quadrant 3 is positive. And finally, in quadrant 4, only cosine theta is positive. Then next, please consider a right angle triangle. And for this right angle triangle, we have the opposite side O, the adjacent side A, and the hypotenuse H. Okay, so for sine theta, it is O over H. For cosine theta, it is A over H. And finally, for the tangent theta, it is O over A. So these are the trigonometric ratios. Then let's take a look at one example. So in the question, it is given that tangent theta is 3 over 4 and sine theta is smaller than 0. And the question asks you to find the values of sine theta and cosine theta. So first, we know that tangent theta is positive and sine theta is negative. So from these 2 information, we can conclude that the triangle must be constructed in quadrant 3. So I will construct the figure. So first, draw the xy axis. Then I will construct a triangle in quadrant 3. Then we know that tangent theta represent O over A. So for the triangle that we construct, okay, we know that the theta is here, and then we have to identify the O, A, and H. So therefore, we know that the O is 3, the A is 4, and the H we are going to find. Okay, one more thing, that is, for the 4, it is on the negative x-axis, so we have to put the negative for it. So similarly, for the 3, it is on the negative y-axis, so we have to put the negative sign. Okay, so therefore, after putting all the information back into the figure, then we can do the calculation. Okay, so first we have to calculate the h using the Pythagoras theorem. So negative 3 squared plus negative 4 squared okay, so h squared equals to 9 plus 16, so it is 25, and h will be the square root of 25, and h is equals to 5. Okay, so for the hypotenuse, it must be positive. Okay, so we don't have to take the negative of the hypotenuse. So we know that the hypotenuse is equals to 5. Then we can find the value of sine theta, which is O over H. So it will be negative 3 over 5. And for the cosine theta, it is A over H. So it will become negative 4 over 5. Then we finish this question. So the second part of this chapter is optimum values of trigonometric functions. So the first thing we have to know is the maximum value for sine x and cosine x. Okay, so for sine x and cosine x, the maximum will be 1 and the minimum will be negative 1. So we need this two information for our calculation. Okay, then next, sometimes we will change a little bit. So for example, sine ax and cosine ax. So for the a, it can be any numbers. Okay, so no matter we use any number in front of the x, the maximum for sine and cosine will also be 1, and for the minimum, it will also is negative 1. Okay, and I can give you an example that is sine 2x or cosine 3x. Okay, so the last thing, that is we take the square of sine and cosine. So we have sine square x and cosine square x. Okay, when we take the square, it doesn't change the maximum for sine square and cosine square. So it's still 1, but for the minimum, it will become 0. So let's take a look of two examples. The first question is y equals to 1 minus 2 cosine 2x. So in order to find the maximum and minimum value of y, we have to put some value for cosine 2x. Okay, also we know that cosine 2x, the maximum and minimum are 1 and negative 1 respectively. So as you can see, there is a negative sign here. So for the maximum point, we have to put -1, so that negative and negative will become positive, so the value will be added up. Okay, so for the minimum point, we will put +1, so that for maximum value it will become 1 plus 2, so the result will be 3, and for the minimum it will become 1 minus 2, so that we have -1. Okay, then let's take a look at question 2. Y equals to 3 sine square x minus 4. So in this case, in order to find the maximum and minimum, we have to put some value for the sine square. Okay, and then for sine square x, the maximum will be 1 and the minimum will be 0. So in order to find the maximum value, we'll put 1, and for the minimum value, we'll put 0. Then we can get the results. -1 and -4. The third part of this chapter is trigonometric identities. Do you still remember we have to memorize all the identities in this table? But don't worry, as we have some patterns for you to memorize. So first, we have to identify 90° plus or minus, and also 270° plus or minus. So for 90° plus or minus or 270° plus or minus, sign will change to cosine. And then cosine will change to sine. And tangent will change into 1 over tangent. Then next, the second step will be we have to consider where does the angle fall. Okay, so for 90° plus theta, it will goes to quadrant 2. Okay, then we have to make use of the ASTC. Okay, so for sine in quadrant 2, it is positive. And then for cosine in quadrant 2, it is negative. And tangent in quadrant 2, it is negative. Then let's move on to 90° minus theta. So it will goes to quadrant 1. Okay, so in quadrant 1, sine, cosine, and tangent are all positive. Then for 270° plus theta, it will goes to quadrant 4. Okay, so for quadrant 4, only cosine is positive. As for sine and tangent, they are negative. And for 270° minus, it will goes to quadrant 3. So in quadrant 3, only tangent is positive, while sine and cosine are negative. Then we finished 90° plus and minus and 270° plus and minus. Okay, then let's move on to 180° plus or minus and 360° plus or minus. Okay, so for this two angles, 180° and 360°, we don't have to change, so we keep it sine, we keep at sine. So similarly for cosine and tangent, okay. So again, for the next step, we have to consider where is the angle. So for 180 degree plus theta, it will goes to quadrant 3. Okay, so in quadrant 3, only tangent is positive. Okay, while the sine and cosine are negative. As for 180 degree minus theta, it will goes to quadrant 2. So in quadrant 2, only sine is positive, while cosine and tangent are negative. Okay, so for 360 degree plus theta, it will go back to quadrant 1. So again, in quadrant 1, sine, cosine, and tangent are positive. And finally, for 360 degree minus theta, so it will goes to quadrant 4. So in quadrant 4, only cosine is positive, while sine and tangent are negative. Okay, so using these two steps, then we can finish all the identities in this table. Then there are two more identities that we will use in these sections, and they are, for tangent theta, it can be separated into sine theta over cosine theta. Okay, this is the first one, and the second one will be sine square theta plus cosine square theta equals to 1. And these are the two identities that we have learned in the junior form, and that will be used again in this chapter. So let's take a look of some example. So for part A, we have sine 180 degree minus theta, tangent 270 degree minus theta over sine 270 degree plus theta. Okay, so our first step is using the identities to simplify all the sine, cosine, and tangent. Okay, so for sine 180 degree minus theta, it will become sine theta. Okay, and for tangent 270 degree minus theta, it will become 1 over tangent theta. Okay, and for sine 270 degree plus theta, it will become negative cosine theta. Then we will consider 1 over tangent theta. So we'll use the property, the identity of tangent theta equals to sine over cosine. Then if we want 1 over tangent, then we will swap the cosine and sine so that it will become cosine over sine. So therefore, in the question, we have sine theta times cosine over sine and then over negative cosine theta. Then we can do the simplification. So in the numerator, we can cancel out the sine theta, so that it will become cosine theta over negative cosine theta. So again, one more cancellation, that is the cosine theta, then we can get the final answer, negative 1. Then let's take a look of part B. We have sine 180 degree plus theta over cosine 90 degree plus theta minus sine square 360 degree plus theta and tangent square 270 degree plus theta. So we'll do the simplification one by one. Okay, so for sine 180 degree plus theta, it will become negative sine theta. Okay, and for cosine 90 degree plus theta, it will become negative sine theta. Then let's take a look of sine square 360 degree plus theta. So we will do it in this way. So first, we will consider sine 360 degree plus theta. And the result will be sine theta. Afterwards, we will take the square on both sides. so that it will become sine square theta. Okay, then we will consider tangent square 270 degree plus theta. Okay, so again we will first consider tangent 270 degree plus theta, and it will become negative 1 over tangent theta. Okay, and we will then take the square on both sides, and don't forget the negative, we have to square it also. Okay, so the result will be tangent square 270 degree plus theta equals to 1 over tangent square theta. Okay, so we can write the results back into our question, our answer. Okay, so that it will become sine square theta times 1 over tangent square theta. Okay, next we have another things to deal with, that is the 1 over tangent square theta. Okay, so we'll use the result in part 8 again. Okay, so that is the 1 over tangent theta, that is cosine theta over sine theta. So therefore, when we take square on both sides, for the left hand side we will have 1 over tangent square theta, and for the right hand side we have cosine square theta over sine square theta. So we'll use this to represent 1 over tangent square theta. Okay, so for the next step we have 1 minus sine square theta times cosine square theta over sine square theta. So as you can see, the sine square theta can be cancelled out, and we will have 1 minus cosine square theta, and we can get the final answer, that is sine square theta.